Hi, my name is Gurneet Jawanda. Today I'll be presenting a presentation on solar energy. I will be focusing on scientific foundation of solar energy, and then I will be talking about solar panels and battery technologies and some of the issues that they have. So, first of all, solar energy, it originates from a nuclear fusion that happens in the sun. Hydrogen nuclei, they fuse into helium, release enormous energy in the form of electromagnetic radiations. Then the tiny fractions of those radiations, they reach Earth, where it becomes the most abundant renewable resource. Sunlight contains photons, particles of light, which travel through space and deliver energy when they strike matter. And usually, the amount of energy arriving to Earth is about 1000 watts per square meter. And there are two ways for solar energy that we can convert into electricity through solar thermal and solar photovoltaic. So in this presentation, I will be talking about solar photovoltaic. I'm sorry. Yeah. So when we talk about solar panels or photovoltaic cells, they work through the photovoltaic effect. In these cells, photons they strike to semiconductor, and they they strike to semiconductor. Usually it's silicon. Then they make the electronics excited and then cause them to flow, which does generate direct electricity. So there are two types of layers of silicone that can be used in these panels. One is N-type layer that has extra electrons, and then another one is P-type layer that has electron vacancies, or they can call as holes. And where the layers meet, they we call it p-n junction. So the sunlight energizes electrons across the junction that produce electric current. Typically, commercial panels they convert about 18 to 22% of incoming light into electricity, but their efficiency depends on weather conditions, on material that is used that we are using, orientation of the panel, and then weather, and then even the cleanliness that does matter in this situation. And there are there are some pros and cons. There are some pros and cons to this whole process. The pros are the energy is renewable and abundant, and when it's operating, it does zero emission, and it works on many scales. For example, home to utilities. And the cons are the cost, the upfront cost you have to pay in advance, and the cost is not really effective. And then even the intermittency, it only produces energy during the daylight, and reduced performance. For example, in cloudy climates, it does not produce that much energy. Next, I will be talking about battery technology. Solar output fluctuates throughout the day. Batteries store excess electricity for use at night or during low sunlight conditions. As solar adoption grows, efficient storage becomes increasingly important. The most common battery that is used is lithium ion battery. The main storage technology that is used today. They work by moving lithium ions between the positive and negative electrode through through an electrolyte. They offer high efficiency. They offer high energy density and long cycle life. Key issues to this is the lithium, cobalt, and nickel. extractions. They raise concerns about water pollution, land degradation, or even human rights issues as well. And the batteries, they gradually lose their capacity, and they are still very high compared to the traditional energy storage, and their cost is very high. And current recycling capacity is very limited, even though it's growing, but it's still limited. And when we look at the future, we want to have something, or we should have targets of something that can help and reduce dependency on rare material, for example, lithium or cobalt. And we need something that has more recycling benefits, and we also need something that has more lifespan and that is more safe to use, and um, that is cheaper than the current batteries that we use. We need cheaper alternatives, and yeah, that is it. And I do believe that energy offers a clean, abundant energy source, but its effectiveness depends on continued advances in both photovoltaics and battery storage. And thank you.